Okay, so lesson 3-2 today, or 6-2 today, excuse me, 6-2, page 315 in our books, right? 315. So here we go. We are going to analyze reflections today. So we've already talked about lesson 1, which was translations. And translation is basically just sliding something to a new spot, right? But with reflections, we're going to flip it. It's like a mirror image. So we're going to reflect it across a line. Here we go. Warm up. Question. Dale draws a triangle on a grid paper and labels it figure 1. Then using his pencil as a guide, he draws another triangle directly on the opposite side of the pencil, so the vertical side is now 1 square to the right of the pencil instead of 1 square to the left. He labels this triangle figure 2. How are the figures the same and how are they different? Mason.
They have same height, like they're the same size.
Same size? Good.
They're just inverted.
Okay. So it's like a mirror image of each other, but they are the same size, the same shape. What about the angle measurements?
Same.
Angle measurements would all three be the same, 3 angles. Side lengths would all be the same length. They are the same distance from that line, from the pencil, right, that he used as a line of reflection. That's going to be an important thing for us to remember as we move through this lesson. How are they different? Yeah, they're facing different directions, kind of is a good way of saying it. They don't have the same position on the page, right? That was one thing we noticed with translations yesterday. What changed was their position. So we're definitely changing position today, but we're also changing orientation on the page. Okay, so there you go. There's more differences today with reflections than there were yesterday with translations. All right. Here we go. Everybody's favorite part of the lesson, the part where I'm quiet and the video talks.
How does a reflection affect the properties?
Let's try that again. I'll plug in the actual sound system. Forgot something. There we go. Okay, here it goes.
Of a two-dimensional figure. Think about this question during the lesson. The client wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? Can a picture or an object be used to represent the problem situation?
Okay, so the grill is this thing right here. And yesterday, or 2 days, I guess, whenever we did lesson 1, we talked about moving the fire pit, right? And so we translated the fire pit. We just slid it, and nothing changed as far as like changing its orientation. It just changed the position. But think about a grill. Have you ever seen a grill work? And a grill has a front and a back, right? Fire pit is just a square. It's got 4 sides. It doesn't have a front and a back. But the grill has a front and a back. You got the lid on it that you open up so that you can grill stuff. It's got the controls on it to set the flame height and all that stuff on the front. And so if we just translate this grill, if we just slide it straight across and put it on this side of the patio, then what problem do we have? It's okay to speak. Bryson. It's not facing the right way. We'd have to stand off in the yard or down off the patio because we can't see the front of the grill. And so we have to change the orientation of the grill for the grill to be useful to us on the patio. So that's why it needs to be a different type of translation. Sometimes a transformation. Sometimes we need to move things differently than another method of moving it. Okay, so the grill should end up over here on this side of the patio, but it's not just a simple translation that'll do it for us.
The architect flips the placement of the grill over the vertical line segment reflection, or flip, is a transformation that flips a figure over a line of reflection. Reflected figures are the same distance from the line of reflection, but on opposite sides.
That is a very important thing she just said. It's the same distance from the line of reflection. So if this is a true line of reflection, then the grill on this side where it started is the same distance from the line on this side where it ends up. Okay?
Where will the grill be placed after it is reflected?
Select your answer.
Softball question. Where's it going to end up? A, B, or C?
That is B.
B.
Remember where the original location of the grill is. Watch as the location of
Are
the
you
grill
watching?
is reflected.
There it is.
Here's the new location of the grill. The original location and the new location of the grill are the same distance from the line of reflection. The reflection of the grill is the same distance from the center, but on the opposite side of the patio. The grill still has the same shape and size. However, the orientation, or direction the grill faces, has changed.
All right. What happens if we move the line of reflection? Then we move the placement of the image, right? Remember what our original, we called it? It's not, we call the copy the image. What do we call the original? The pre-image, right? So you have the pre-image where it was at originally, and then if we change the line of reflection, we change where the image goes, because they have to stay the same distance from the line of reflection. That's like the big thing for this lesson. The line of reflection has to be exactly halfway between the two objects.
Mr. Fish,
Yes?
can you see how far the line goes?
I can yeah, we can put the grill in the neighbor's yard if we want to. I mean, we can put the grill all the way down the block. Like, okay, so there you go. And we can even go to the other neighbor's yard. But I can't go up or down. I can only go across. Awesome. Good question. Whoops, there we go.
Now, you know that a reflection affects the orientation of a figure, but it doesn't affect its size or shape.
There you go. It affects its orientation and its placement, but not its size or shape. All right. They keep showing us this drawing here, and the only thing left on this whole drawing that we haven't talked about is this little piece right here, is the chair. So if we're going to reflect this chair across that line of reflection, where is it going to end up?
On that side?
On the other side. That's the best way I know how to say it. And it should be about this, best we can, the same distance from the line of reflection. Now it's just kind of sitting there in the middle of the patio.
Let's go.
All right. Cool. All right, guys, reflection, super simple. Just amounts to counting, once again, basically, for what we're doing, just like translation was. So they're going to start us out here. Polygon ABCDE has vertices at those locations. Graph and label the vertices of ABCD and its prime after reflection across the x-axis. They're always going to give us a location of what we're reflecting it across. Often it's going to be either the x-axis or the y-axis, though we're going to get into some other lines as well. It can be any line. We can make our own lines of reflection. But we are going to, in this case, reflect across the x-axis. That's this line right here, right? Super simple to reflect, guys. All you've got to do is count. I'm going to start at point A, and I'm going to count. 1, 2. It took me 2 to get to the line of reflection. So how far should I go past the line of reflection? 2. So 1, 2 more. Right there is where they should put point A prime. And guess what? That's exactly what they do. They count from the point to the line of reflection and count that same number to the other side of the line, and they place their point. Okay? Guess what they're going to do with points B, C, D, and E? They're going to count to the line of reflection, and then they're going to place those points that far on the other side of the line of reflection. There it is. So for B, it was 1, 2, 3, 4, and then B prime is 1, 2, 3, 4. It really is that simple. It's counting, okay? And once you have all your points drawn in, then you can fill in the shape. The corresponding side lengths and angle measures remain the same, just like with translations yesterday. So angle E is the same measure as angle E prime. Angle side length BC is the same length as side length BC prime, okay? Does that make sense? It's pretty simple. What if we don't have a graph, doggone it? They give us quadrilateral KLMN and give us the locations for those things, and then they say it's reflected across the y-axis, resulting in KLMN prime. What are the coordinates of N prime? Well, we're going to reflect across the y-axis, and we know that N is at 3, 2. So let's go to another screen, and we're just going to worry about that point. I'm not going to draw the whole shape. So if we go to this screen, okay, so point N was where? 3, 2. So 3, 2 is right here. This is N. Everybody agree? Okay. So I want to reflect where? Across the y-axis, it says, right? That's this one. This one's x. So all I got to do is count 1, 2, 3, and then count 1, 2, 3. So N prime goes right here. What is the location of N prime? -3, comma 2. There's an interesting relationship between those 2 points, right? What do you notice has changed when we reflect across the y-axis? The x value changed signs. Okay, so if I start with a positive x value and reflect across the y-axis, I'm going to have the same number. It's just going to be negative for my x value. But what about the y value? Stays the same, right? Okay, what do you think would happen if we reflect across the x-axis? The y value would change sign. So if I reflect my point N across the x-axis, go 1, 2, 1, 2, and we would label this one N double prime. Ooh, that's tricky, right? Because this is N prime, our first reflection, and this would be our second reflection, N double prime. So we would call that one 3. The x value stays the same, but the y value changes signs. It's a little bit confusing if you don't follow it. If you reflect across the y, the x changes signs. If you reflect across the x, the y changes signs. Okay? Once you have that straight in your mind, it's pretty simple, but when you're trying to sort it out for the first time, it's confusing because the x's and y's go back and forth like that. So back to the problem we looked at in the book here. If we're just reflecting across x or y axis, it's pretty simple to answer these questions once you understand it. So where is N prime? It's going to be -3, 2, because I know we're reflecting across the y, so the only thing that changes is the x value. Okay? All right. We also need to be able to write a rule. If they give us the picture of a reflection, can you tell what the reflection was? Okay, so here it is, my original shape, ABCD, and now my new shape is ABCD prime. So which way did we reflect it? Well, it's pretty easy to see, isn't it? I reflected 1, 2, 3, 1, 2, 3. The point A is 3 away from the y-axis, and A prime is 3 on the other side of the y-axis. So we reflected across the y-axis. Does that make sense? Not hard to see once you, or not hard to do once you see it. Now, here's where it changes a little bit. We don't have to use the x or the y axis as the line of reflection. That makes it a little bit trickier. First of all, you got to remember back to where we did some linear stuff, and you got to understand what x equals a number and y equals a number means. So the first thing we're going to do here, polygon ABCDE is reflected across line x equals 2, or sorry, x equals -2. Where on this graph does x equal -2?
On the line, it's like, I don't know, I can
Okay,
show you, but-
so if this is 0, 0 right here, where do I go to find x equals -2?
Left two.
2 left. Okay, so this spot right here would be -2, 0.
Yeah.
Okay, and anywhere on this line right here, x is always going to be -2 on that line, right? Okay, so -2, -5 down here, -2, 0, -2, +5 up here. X is always -2, so that line is x equals -2. Now I can reflect across that line, right?
Yep.
Okay, so it's pretty simple. All I gotta do is put points. So point A, I would go 1, 2 to get to the line, and then 1, 2 right there to plot my point. For B, right, I did point. Yeah, I did that. Okay. Oh, okay. I'm good. Point B is 1 to the line, and then point B is right there. C, 1 to the line, and then, whoops, I missed it. How do I get rid of 1? No. Ooh, I didn't know I could do that. That's gonna make things easier. I just have to start over. Okay, so I need to put my line of reflection on there, which is this line, right? Okay. And now don't hit the wrong spot. So 1, 2, 1, 2. There's A, there's B, there's C. D is 1, 2, 3, 1, 2, 3. And E is 1, 2, 3, 1, 2, 3. Right there. And then we can fill those in. And the thing I can't do on here, I don't think, is label them. I don't have a writing tool on this screen. But I've made my shape, okay?
Awesome sauce.
Awesome sauce. Okay, guys, it's that simple. We're counting. We're going to the line of reflection. We're counting to the other side of the line of reflection. Sometimes we have to find the line of reflection. So that's what we're doing. The assignment is what pages? 319, 320. Go ahead and turn there. I've got all of the problems right here. We're going to just work through this. If you want to work ahead, you can, but I'm going to work through these. Part number 7. So, I'm still recording, by the way. So if you're working ahead, work ahead quietly. Number 7. So trapezoid ABCD is shown. Draw the reflection of ABCD across the y-axis. So we've got to label our original points. We've got to label our new points and draw the reflection. So, what is point A? Where is that at? 2, 8. Where is point B? 6, 8. Point C? 8, 3. And point D? 1, 3. Okay, so we just learned that if I'm reflecting across the y-axis, what value is changing in my ordered pair? Am I changing the x or the y? I'm changing the x, and I'm just changing the sign. I'm leaving it the same number, I'm just going to change it from positive to negative. Okay? So I can do this real quick. Without even graphing these, I can say that's -2, 8. This is -6, 8. This is -8, 3. And this is -1, 3. Now I just need to graph them. I've got the ordered pairs. I can use those to graph. I can count to graph, however we want to do it. So -8, 3. And then get my straight line tool so that I can make straight lines. You guys still should be using rulers in your books or straight edges. I did not label them, I should do that. A prime, B prime, C prime, D prime. That one does all the stuff, right? I hope it's easy. Some of them they get a little bit tricky with. They give us some weird lines of reflection here in a minute. Okay. Is ABC prime a reflection of ABC?
No, because it's facing the same direction.
It's oriented the same direction. It's a translation, not a reflection, right? So, no, it's fine if it's a translation, is what I would say. Okay? Your friend gives you the graphic quadrilateral ABCD and its image. What reflection produces this image? How do we find the line of reflection if we don't know what it is? By counting. Let's go so count from where to where? B to B prime. 1, 2, 3, 4, 5, 6, 7, 8. Where does the line of reflection need to be? At 4. It needs to be right in the middle of those two. So I need to go 1, 2, 3, 4. And then I can go from the other side. 1, 2, 3, 4. Look at that. That's the middle spot between the two B points. And so I can put a line of reflection right here. And what is that line of reflection? We would just say, what is the value of X on this line? Whoops.
1.
Yes, the value of X on that line. What did I do? How did I even do that? Okay, the value of X on that line is 1, so we would just say X equals 1. That's the line of reflection. Okay? X equals 1 is the line of reflection. Your friend incorrectly says that the reflection of EFG to its image is a reflection across the x-axis. Is it a reflection across the x-axis? No, because a reflection across the x-axis, 1, 2, 1, 2 would put G prime right there, and that's not where it is. So, we need to find the, what is your friend's mistake? Well, they miscounted or misunderstand what a reflection is, or some, I'm not exactly sure how you would make that mistake, but I would say probably they miscounted. So how do we find the proper line of reflection? You gotta count. 1, 2, 3, 4, 5, 6. So it's gotta be in between, which makes it at 3. 1, 2, 3, it's right here. So if we have vertical lines, our X equals a number, what are our horizontal lines? On the last one, it was X equals 1, because it was vertical. This is going to be Y equals what? -1. Reflect across Y equals -1. That's how you would describe that transformation, that reflection. We need to reflect across the line Y equals -1. Does that make sense? Alright, makes sense. The vertices of the shape ABC, triangle ABC, are reflected across the line Y equals -1. Find the coordinates of vertex C. Okay, so now They changed it up a little bit on us, because if we just reflect across the y or the x-axis, it's easy to know how to change the numbers. But when we reflect across different lines, we have to think about it a little bit. So, so let's think about where point C would be. Point C is gonna be on a graph at -2, so we can draw a picture if it helps. So if I have a graph right here, and C is at -2, 3, maybe about right there. Can you picture that? Is that -2, 3?
Well, okay.
Okay,
I have the answer.
so, okay, so what is the answer?
-2,
Not quite, because we're not reflecting across the x-axis. If we reflected across the x-axis, that's exactly what it would be, but that's not what we're reflecting across.
Well, how are you gonna
We're reflecting across this line right here that goes just below the x-axis.
Yeah, but it's, oh, wait, no, -4, my bad.
Okay, so how far is it from -2, 3 to get to this point right here? Say, 4, it's 4. So I would go 1, 2, 3, 4, and right here is at -2, comma, -1.
-5.
And then I've got to go 4 more. So it would be down here, which would be -2, -5. Okay?
Let's go.
Alright. So that's, I mean, it's a little different process we gotta go through. You gotta kind of picture where it's at. You gotta think about how far you moved it to get to the line, and how far you have to move it across to get to the other line. So C prime is at -2, -5.
Oh, you explain 12.
I'll get there. Okay, everybody good for 11? Number 12. Notice that the shapes overlap each other, right? That means that the line of reflection goes through the middle of them. The line of reflection, like, you know, on this one, the line of reflection is between the shapes. The shapes are a long ways away from one another. So here, when the shapes overlap one another, that means the line of reflection goes through the middle of the shapes. So just pick a point, A, B, C, or D.
A.
A. Let's go from here to A prime. So how far do we go? 1, 2, 3, 4, 5, 6.
6.
So what's halfway?
3.
Alright, so 1, 2, 3 is right there. 1, 2, 3, it's halfway from both points. So this is my line of reflection right here. So what is that line? Y equals 3. The line of reflection is Y equals 3. Does that make sense?
Yep.
Anytime you need to find the line of reflection, just choose 2 points, find the middle spot between those 2 points, and that'll be your line of reflection. Okay? Alright, number 13.
Well, this one's easy. It's B.
JAR has vertices, and what graph shows JAR is after reflection across the line of x equals 1. Couple of things I want to talk about. It is easy to see if you know which one you're looking for. X equals 1. So this one, A would be 1, 2, 3, 4, 5. I don't know how I just did that. 5 between J and J prime. And so in halfway would be 1, 2 1/2, which would be what the line of reflection would actually be down the middle, which is 1 1/2. So that's okay to have that as a line of reflection. That's just not what we're looking for. So for B, 1, 2, 3, 4, 5, 6, 1, 2, 3 puts the line of reflection right here. Okay? So that works. What's wrong with D?
It's not reflected. It's a translation. Not really, but.
It's, D would be like they reflected it and then translated the reflection. They reflected it across and then moved it down one. And that you can do that. We could put series of transformations in a row, and you could do more than one step. But that's not what they asked us to do. What's wrong with C?
Oh, they flipped the angles, or the.
They're not labeled correctly. Okay, you have to label it. Angle R prime is not a copy of angle A, and so you can't change the order of the letters like that. Okay, so that's an important one. We don't talk enough about that one. All right, so the measure of angle A is 90 degrees. What is the measure of angle A prime?
90 degrees.
Gotta be 90 degrees, guys. 90 degrees down here. Okay, so, all right, good talk. That will be all we're gonna do today for this. On tomorrow, you'll have an IXL assignment that goes with this lesson, and which is Thursday. You'll have an IXL assignment that goes with this lesson. You also have other IXL assignments that are due. Make sure those are all turned in.